Hello again, everybody. In this video, let's combine our knowledge of loops. We have the for loop, we have the while loop, and with Python. And now we also know how to use Turtle Graphics to make some nice designs and draw lines and such. So let's see if we can combine the loops and Turtle Graphics to plot some graphs. So we'll do a kind of a graphing calculator here, kind of a primitive one. But at any rate, maybe it will be fun. So let's give it a try. The first thing I want to do is I want to generate some coordinates, okay, for the simple formula, y is equal to x squared. So we're going to take the value x, we're going to square it, and then we're going to plot x versus y on a graph. To begin with, what I'd like is to just generate a table so that we can see what the numbers are. There's a problem that we'll have here because we need to scale this a certain way, and that's why I've got the scale factor showing up here. In the Turtle Graphics, we have just the pixels out there. So each pixel is very, very small. So if we want to plot something, we probably will need to scale it up so that we can actually see it better. So let's start by printing out the values that we could get. And here is a table that I'm going to produce with a for loop. So this just says we want to generate a table for x squared, and we're going to go from x is minus 20 up to plus 20. So I chose that range because I know that the layout of my canvas for the turtle is about 400 by 400. And so that means that this is going to fit on my chart when I decide to actually generate the plot itself. Now, let's look at the first part of this. I guess I should have done that already, but let's look at what we'll need to do here. Coming up, we are going to use some math functions. So if you want to use the math functions, and there are an abundance of them, Python has a lot, and we'll take a look at some of those shortly. But we'll need to import the math library. So that gives us the capability to use a lot of the functions like sine and cosine and absolute value and lots of other things. The other stuff you see here is the same thing that we've used as in order to use the Turtle Graphics. So we just need to import the turtle, and then the get screen activates the screen. And then just as a shortcut, we're going to assign this variable t to be our turtle command, so we don't have to type out turtle every single time. Now, let's just generate a table of values, as I said. So I'm going to print out x, and I'll print out x squared. And then we just have our for loop. This time, we're going to be dealing with integer values, so it's okay. With a for loop, we know that this thing here, whatever we're using, that can't be a real number, so it can't be a fraction. But it can be an ordinal type. It can be a character, an element of a list, or an integer value. So I'm going to start at negative 20 for the value of x, and I want to go up to positive 20. But as you know, if we want to go to 20, we have to put one more here, which is 21. And my step is just going to be 1 this time. Okay, so we could easily change that, and we could go for x could be minus 20, minus 18 if we went by 2, and whatever we want to choose here. But I'm going to start with 1. Now, to generate x squared, here is the exponentiation operator. That's 2 asterisks side by side. So that gives us the power of something. Okay, so if we want to calculate x squared, we have x, and then the 2 asterisks, and then a 2 here for x squared. If we wanted x cubed, we'd put a 3 there. If we wanted x to the 4th power, we'd put a 4 there. So this number can be, whatever power you want it to be. Then I'm just going to print the table. So I'll print the value for x, and I'll print out x squared. Okay, so instead of using y here, I called it x squared. Now, one thing I should probably point out, this little upward circumflex symbol, I'm just using that as a symbol to show that I'm squaring x in the comments. That is not a legitimate, actually, that's not a real operator. Okay, if I had x and then a circumflex here, it would kind of ignore it. Okay, so at any rate, the exponentiation operator is 2 asterisks next to each other. Let's run the program, and let's look at the output that we get from this. So I'll click the run, and I do want to save it. Now I'll bring in the window so we can see what the output looks like. All right, so I have quite a few numbers. I go from minus 20 to plus 20. But here you can see the table, right? So it's easy. We have x here, we have x squared over there. So you know the kind of plot we're going to get eventually. You've seen them already. So if we square a negative number, we get a positive value. So our first point will be x will be minus 20, y will be 400. And as we gradually proceed through the for loop, you'll see that we decrease by 1 each time. And at the bottom, we have 20, positive 20, and the result is 400. Now, if we think about this, if we think about plotting it, then we know that the values need to be in the range of about 400 pixels maximum. So I think that my values here for x squared are going to be okay. They will fit on the canvas just fine. The values for x, that's minus 20 pixels here, and that would go up to only 20 pixels. So that would be a very, very skinny plot. But I will show you that. We will plot these now, but we will need to come back and we'll need to set a scale. And I've got the scale up here, scale times 10. So we will need to multiply this x value by some scale to make our chart look better. So if we want to plot this, then let's bring in some of our Turtle Graphics commands and let's prepare to draw a plot of these numbers. Now, you know the Turtle Graphics canvas, it starts out blank. So one of the first things I want to do is I want to actually draw the axes. Okay, so I want to see the x and y axes traced out. So I want to start with that. So let's put some Turtle commands here to do that. All right, so here we have the statements. All right, so let's make a plot. Draw the axes. So I am just going to take the turtle. I'm going to raise the pen, and I'm going to go to a negative x location of minus 400 and a y value of 0. Then I'm going to put the pen down, and I'm just going to draw across from left to right on the x-axis 400 up to location 400. That'll just draw a line along the x-axis. Then I'll raise up the pen, and I will go up to location 0 for x, minus 400, which is way down at the bottom. Then I'll put the pen down, and I'll draw a line up to positive 400 at x location 0. So that just generates the x and y coordinates so we can see them. Then I'm going to raise the pen and send the turtle back to the home location, back to home base. Now there's a few other things that I'd like to do, and that is I want to kind of just set the thickness of the line. To begin with, it's only going to be 1 pixel. So I'm going to initialize some things for the turtle. First of all, I'll just set the pen size to 2. That'll give me a thicker line. And then I need to send the turtle to the beginning location. So let's put some code here to do that. So I'll paste in these commands. Okay, so let's put that over here, otherwise it will complain. And then I will move the turtle to the location of the first coordinates to be plotted. Having trouble talking today. All right, so I'll set the pen size to 2, and then we'll do a pen up. And I know by looking at my numbers that the starting point was x is minus 20, and the y coordinate is 400. So I want to move the turtle over there. Okay, now I said I was going to wait about the scale, so let me take the scale off to begin with, and we'll just see how skinny that parabola is going to be. All right, so this prepares our turtle. Then we just need to go and draw out the line. Okay, so let's put the code here to do that. So in it goes. So now we'll draw the curve. So we went over here, right? We did a pen up. We went to this location. That's where the first plot point will be. So let's put down the pen, and then we have almost the exact same line or same for loop that we used up here when we generated the numbers. But this time we want to use those numbers to send the turtle to various places along the canvas. Okay, so once again, I'll take the scale out here. So we have the very same thing. We have for x in the range minus 20 to 21, we compute x squared. I'm going to set the color to red, and I want to draw a red dot. So for each of the coordinates, I'm going to draw a dot, and then I'll connect those by using this go-to statement here, which moves the turtle along, and as long as the pen is down, it draws wherever it goes. Okay, so now let's see what kind of plot we get. Okay, so now we can see the turtle. So we have drawn the axes. You can see those. You can see the lines here going along the x-axis and the y-axis. And here's the plot. So you can see that our plot is very skinny. And that's because we just went from 20 pixels to the left of the origin over to 20 pixels to the right. So if we want to make this just appear better, we need to scale our x value. So let's add a scale back in. And I did have that already, so I need to just go back and put that in. So I'll put those back in here. So the starting point is going to be minus 20 times our scale factor, and then each time I plot a value for x, I'm going to multiply it by the scale factor. And the scale factor right now is set to 10. So we'll run the program again, and we'll see if we need to increase the scale factor even more. All right, so I'm going to click Run. I have to say Save. And you can see the turtle drawing the axes. And then it's going to draw our curve of x squared. All right, that looks much better. Okay, so that's a more pleasing kind of curve. And you can see that the actual coordinates are plotted with red circles. Okay, so if we move this over here, then the first one is at minus 20, and I multiplied that by 10, so that x coordinate is really minus 200, and the y value is 400. Okay, so then our table and our loop goes from this minus 20 value to 0, and then back up to plus 20. And you can see the turtle is still up there. I didn't send it back home, so that's the place where the turtle stopped. So then we can use our turtle graphics to plot the equation of pretty much anything we want. We just have to set the x value and the y value. And that's what we'll be doing here with some additional equations coming up. Now, to send the turtle back home, I just need to do a pin up and send it back to the home, which is at the origin, 0, 0. Yeah, before we stop this one, I mean, this illustrates how you can plot the equation of something. Okay, this is just x squared, x is equal to x squared. So we could make this equation as complicated as we wanted to. And just all we need is to get a set of coordinate points, an x and a y value, and we can get the turtle graphics to plot it. Before we stop this example, let's also go ahead and plot something else here. Let's take the derivative of x squared. We know that's a really simple derivative, isn't it? It's just 2 times x. And then let's plot it as well. So I'll make a comment here to that effect that we're going to do that. So I'll just put that in right here. Okay. And now let's draw a curve for the derivative, which is 2 times x. And let's put the code in to do that. So we'll do the same thing. We're going to cover the same range. So that will not have to change very much. Okay, so to prepare to draw the curve for the derivative, I will pick the pen up, and yeah, it's still up here, but just to be sure, I'll put the pen up. Then I want to go to the starting location, and that's the same place as we did before. So we'll use our go to command, and we'll go to minus 20 times the scale, which is now minus 200, scale's 10. And I'm going to location 40 this time. Okay, so that's going to be in the in the x direction. I'm going to go to minus 200, and in the y direction, I'm going to go to minus 40. Why did I go to minus 40? Well, I know that's the starting point. And the reason I know that it's the starting point is because my equation is just x times 2. Okay, note there's only one asterisk there, so I'm just doing an ordinary multiply. Let me separate that a bit. So I'm just multiplying 2 times x, or x times 2. And 2 times x is minus 40. So that will be the first point. So that's why I'm going to go to y minus 40, and the x value is minus 200. So that is where I will begin. The range will be the same, exactly as before, minus 20 to plus 20 with increments of 1. We'll calculate the derivative, which I'm calling 2x, which is x times 2, and then we will plot that. So we have the starting point set up there, and inside the loop we have our turtle goto command. So it will go from that first point to the second point, and it'll plot these values, x times scale and 2x each time. All right, now we'll get an additional curve, and note I've set the pen color to green this time, so we can see that the derivative will be plotted as a green line, and the other one will be plotted as a red line. Now, I'm not actually plotting dots for the coordinates this time. I'm just drawing the line. So let's run the program and look at this output. Okay, so I'll bring our turtle canvas over here and watch it draw. So it draws the coordinates. Now it's drawing the x squared curve. Then it will draw a green line representing the derivative. Okay, so you see here they do cross the origin at 0, as they should. And over here we've got a negative slope, so we see a negative derivative, and here we have a positive slope. So there you have it. We've plotted x squared and we've plotted the derivative of x squared. Now let's modify the program a little bit, and let's just modify it to do x cubed. So we will compute y equals x cubed. Now, since we are cubing things, we need to lower our range, because if I cubed the number 20, then I would go far outside the range of the canvas, and I don't want to do that. So I'm going to go from -8 to +8. So let's first of all, let's generate the table of numbers for that so we can see what the numbers are, and then we can decide if we need to scale them. And let's go ahead and put the code for that. So we'll generate a table for x squared. No, it's going to be x cubed, so let's change that. And let's also change the range here. Like as I said, we're going to go from -8 to +8. So there, that matches. So we'll generate a table for x cubed. Okay, so I'll print out x and I'll print out x cubed as the column headers. And I need to set this up. Okay, that's off a little bit. I want to go from -8 and I want to go to 9, because to go to 8 we have to go to 9, or put 9 here. And here's x cubed. Okay, so x cubed is just equal to x to the 3rd power. So you see the exponentiation operator showing up here. And then we just print those two numbers to the screen. All right, now let's see what those numbers look like before we go and do the loop for the turtle. So I'll run the program, and we'll go take a loop at that. So the turtle comes up. We don't really want that. Let's bring out the numbers across. Come over numbers. So you see the numbers are pretty big. Okay, in fact, the first one, -8, that might not fit on the chart. That's -512. So it will go from -512 to +512. So it's going to go off the charts if I leave it like that. I might want to bring that down to -7 to +7, so the range is 343 instead of 512. But let's go ahead and run it this way first, even though part of the plot will not appear on the canvas. So let's move this out of the way, and I will stop the program, and I'll add the code so that we can draw the coordinates for our axes like we did before, and then we will go ahead and draw the curve for x cubed. So let's put the axis back in. So this is the same thing as we just did. I'm just drawing the x and y axes so we can see them. We can tell where the origin is. And then I'm going to need to send the turtle to the initial position. And we can look at those numbers and we can know what that initial position is. We can go back and just look at the table of outputs. But I'm going to do it this way. So I'm going to, again, I'll make the pen size 2. And then I'm going to pick up the pen, and here's the starting point. Okay, so this does say -7 to -7, even though I have 8 in here. So let me be consistent with that. Let's put an 8 there, and let's put an 8 here. So that's going to be the range of x from -8 to a +8. And the y value is just going to be 8 cubed. All right, so to start out with, the value is going to be 8, and since it's a negative number, then I know that the cubed value is also going to be negative. Okay, so if we have -8 cubed, that will be a negative number. So that's where we will start. Now, I want to send the turtle to that location, and I am going to use the same scale. Remember last time with our scale of 10, that worked out okay when we did x squared. So I'm just going to keep the scale as 10, and I'm going to multiply the x value by the scale. So to get to the starting point, I will take -8 times 10, so that's -80. So that's where the first x coordinate will be. And the coordinate for the y value, I'm going to use the power function for that. Okay, so this is the same thing, -8 comma 3. If you use the power function, then the first number is the number that is being taken to a power, and the second number is the power itself. And I notice I'm missing a parentheses, so let me put that here. So we can do the technique of using the double asterisks to do a exponentiation, or you can use the POW function. Okay, so I'm going to use the POW function just to illustrate how that works. So this will send the turtle to the starting point. From there, we can draw the curve out using our for loop. So let's bring the loop in to do that. So let's see if I have everything right. Okay, see, we will go to this location with the pin up. Then I'll put the pin down, and we'll go through the range of values. Okay, so the range is -8 to +8, and we're going to go in increments of 1. And I said I was going to use the POW function, but I didn't. But let's change this. Let's use the POW function down here. All right, so just to show how that works, then I'm just going to copy, and I'll replace this here with the POW function. But instead of -8, I want to do the value for x. Okay, so x is going to start with -8. And it goes to -7, -6, all the way up to +8. So the x cubed value can be computed with the POW function just like that. Okay, I'll make the dot, I'll put a red dot in there, and I will go to coordinates x times scale and x cubed and go through this entire range and plot out the curve. Now let's run the program and let's look at the plot of x cubed. So we'll start it up, and we can see the turtle draw the coordinates again. And here is the x cubed value. Now you've probably seen this before, with an x cubed value. Then we have negative values, which show up over here in this quadrant. And then once the number becomes positive, from 1, 2, 3, 4, 5, and so on, then it's going to be in the positive quadrant over here to the right. Now this time the scale of 10, we might want to expand that a little bit because it is pretty skinny. And that's just because the numbers go up in a hurry with x cubed. So let's change the scale. Let's make it 20 instead of 10, and let's run this again. So that's why I put the scale up here to make it easy to change. So I'm going to change that 10 to a 20. Then you see the scale shows up down here, and it shows up right there. So I don't have to change those numbers. I can just use the variable scale. So now let's run it again with a larger scale. And we'll watch the plot trace out. There are the coordinates, the lines. And now we've expanded the x cubed curve a little bit. Now, you may remember I said that we kind of run off the chart because the upper limit of my canvas is 400. And I could change that. There's a way to set the size of your canvas. But if I wanted to see the ending points, I would need to reduce the values for x. So let's do that. And we will go back to a 7 to 7 here. So let's just change these ranges to 7 instead of 8. And we'll go from -7, and we'll need to make that an 8 for the range, for the range part of it. And same thing down here. I want to go to -7 to start with, -7 for the y coordinate cubed. And I need to change that from 7 to 8 here. And I think that's all I need to change. So this now is going to go from -7 to +7. So let's look at that chart. So we'll get to see it draw. And now it's all on screen. Okay, so you see the first point down here, we plot it, and then we move up our x cubed value, and we go all the way up there. And I did not put a dot on that last coordinate up there. But there we have a plot of y equal to x cubed. Now for the last example in this video, let's do the absolute value of x. Now before we get into that, I just want to bring over some information about the math library in Python. You can find this in the Python reference if you go to python.org. Then you can find all kinds of information, of course. That's the home of everything Python. But in particular, here is some information about the math library. Now I'm just going to scroll through some of these, and you can see that there are quite a number of them, and they do all sorts of things. So if you are looking to do a particular math operation, then you need to check out this math reference first, because you probably will find what you're looking for here. So I'm going to scroll down to some of the things that we've just done. You can see lots and lots of them. So we have some of the power and logarithmic functions, and I did the power function, so that's shown right there. So this describes the power function. And as you can see, we have the log functions are out there, and you have the exponential functions for e raised to some power. They're all there. You also see we have the trigonometric functions that are all in here. So there's a lot. There's a lot of different things that are available to you in the math library. Now, the next one I want to do is the absolute value function. So the absolute value function is one we're going to call, and of course all that does is to make sure that all the numbers are going to be in a positive value, either 0 or a positive value. And if we look at the documentation, then here's this, and it doesn't have much to say. It says returns the absolute value of x, which is, of course, that's what it does, right? Okay, so now let's write a program that will plot that. The first thing I want to do is what we did earlier. I just want to go ahead and look at the table of output values. So let's generate a table for absolute value of x, where x goes from minus 300 to plus 300. So let's print out that table first. So let's put the code here to do that. Then we can examine the numbers, and we can see how big they are. Now, you don't really need to do this if you're wanting to plot values with the turtle, but in order to determine whether or not you need to scale things, it's a good idea to know what your numbers are going to be. So that's one reason I'm putting this table in here, so we can see the numbers. Okay, so I'm just going to print a table, x and the absolute value of x. And the range of values is x will be from minus 300 to plus 300. And I'm going to go in increments of 20 this time. There's no need to go by 1, so we'll just skip by 20. And we'll plot out this equation. Now, when you're using the math library, then you have to use the math dot in front of everything. So we are going to calculate the absolute value of x. We're going to use math.fabs, so that gives us the absolute value of the value x. Then I'll just print those numbers out, x and absolute value of x. Now, I will save time by not showing you that table right now. Let's go ahead and put the code in to do the plot. So I'm still using the same axes, so I'm leaving the code in that we used already to do that. And then I'm preparing the turtle. So I do need to send it to the first location. So to do that, then I need to put this code in for that. So let's put it in here. And this one's easy to figure out. So we know we need to go to a value of minus 300 for x. And if we're computing the absolute value, that will be a plus 300. So it's pretty easy, right? We can go to minus 300, and I could just put in plus 300 there. But I'm using the math function again here, right? So I'm just going to let the math function figure out the y value, which will be the absolute value of negative 300. Okay, then I'm just going to go ahead and set my dot up to be red, and this will plot a dot at the beginning location. Now we need to go through the loop, and that will print out the curve, or draw the curve. So let's put that in here. So we'll put the pen down, and the range will be minus 300, plus 300, increment of 20. X is x, and the absolute value of x is calculated here. Then we move our turtle to those two coordinates, x and x absolute. And then I'm also going to draw the coordinate there, that point with a dot. All right, so that program now will generate a plot of the absolute value of x. So let's run the program and watch it do its thing. Okay, so here is the canvas, x and y axes, and x versus the absolute value of x. So when we get to 0, we know that 0 and the absolute value of 0 is the same thing. But with x over here in the negative direction, x is all the way over here to minus 300. The absolute value of that is the y value, which is this value up here. So as x decreases, gets moving towards 0, the absolute value goes down, and this is all the way over here is minus 20, because we were going in units of 20. So we have 0, and then we have the plus values, and of course the absolute value of a positive number is a positive number. So we get this nice V plot of the absolute value of x. So it's kind of neat. We can use our Turtle Graphics to do a graphing calculator. Now, this video now has run to almost exactly 30 minutes, and that's as long as it needs to be. But I've got more examples to show you. But I'll stop this video here, and then we'll do the next video, and we'll look at some additional functions that are included in the math library. So goodbye for now.